Question 6a, consider the function f of x is equal to negative x to the power of 4 plus 8x squared plus 5. Part of the graph of y equals f of x is shown below. Write down the y-intercept of the graph. So we could type this into the calculator straight away, start messing with the window, etc. Or we can look at it and say, right, we're looking for the y-intercept. We're looking for where the graph cuts the y-axis. And this usually happens when x equals 0. So the f of 0, the function, the output of the function when the input is 0. So we're going to have negative 0 to the power of 4 plus 8 to the 0 squared plus 5. It's 5. So the y-intercept of the graph, y equals 5. 0, 5, I'm sticking with 5 because it's asking for the y-intercept rather than the coordinates. It is known that at the point where x is 2, the tangent to the graph is horizontal. Find 2. So when x is 2, x is positive to this side, to the right-hand side, and it says the tangent to the graph is horizontal. This value here is where a tangent would be horizontal, which means this is going to be 2. Find f of 2. Well, we've got a calculator. Let's use the graph. Let's use tab. So we'll do negative x to the power of 4. What is it? Plus 8x. Let me just check. Squared plus 5. Press enter. Okay, we've sort of got that picture, but it doesn't quite seem right. So let's just menu, window zoom. Let's change the domain and range. Window settings. We'll change to negative 5 and 5 on our domain or our x values. Don't really need to change the minimum, but I want to be able to see what's happening up here. So let's hit 20. Okay, we're still missing these bits, but we're interested in the maximum. So menu, analyze graph, maximum. We know it's off the screen up here, so what we'll do is we'll do this, and the calculator will actually jump to that point. So the point we're looking at is 221. So f of 2 equals 21. We're looking for the output. There are two other points on the graph where f of x, at which the tangent is horizontal. Write down the x coordinates of these 2 points. Well, if we know this point, we know this point, and we've also got that value. So by symmetry, we can say x equals negative 2 because it's symmetrical, and x equals 0 from the original question. Write down the intervals where the gradient of the graph y equals f of x is positive. Okay, it's basically saying where is our graph going up, okay? So if we start on our graph here, we are definitely going up at this point. And we're going up until we get to here. So, and we know that that is negative 2. So any value to the left, our graph, our function is going up. It's going down in this section, so we're going to ignore that. But then at x is 0, it starts to go up again until we get to the 2, and then it's going down. So really, we're trying to describe the domain of those values. So we can say x is positive when x is less than negative 2, and x is greater than 0 but less than 2. So we're describing the domain a little bit there. Write down the range of f of x. Well, the range is the values of the graph. Now, we found the maximums. We know that the input of 2 gives us an output of 21. And we can see any number below 21 gives us a graph. There's a part of a graph there. So the range is the set of values for y such that y is less than or equal to 21. And if you really want to add that, y belongs to the real numbers. Write down the number of possible solutions to the equation f of x equals 5. Right. Let's just clear this picture up a little bit. So we know that's -2. I don't think we quite need that. We're looking for the output of 5. F of x equals 5. So the output is our y values, and we've already been told that y equals 5 at this point. Now, if we look across from here, we can also see there is a value here. There is a value here for x, and there is a value here. So we have 1, 2, 3 possible solutions. I'm just going to put 21 back on there. So when the output is 5, there are 3 inputs we could have whereby we get the answer of 5. So 6f, 3 solutions. Finally, the equation f of x equals m, where m belongs to R, has 4 solutions. Find the possible values of m. We need to look at the graph, and we need to try and decide where can we draw a horizontal line where we cross the function 4 times. Where could we draw that? At 5, we have 3 solutions. So there's 3 solutions here, but as we go slightly up, we're now into 4 solutions. 1, 2, 3, 4. And we get 4 solutions all the way until we get to here, where we end up with 2 solutions. So this region, or this range, is the values whereby we have 4 different solutions. There are 4 places where that line crosses. So m, the possible values of m are greater than 5 but less than 21. Those are the values that we would expect to see for m.